Hello guys, good evening. You are welcome to my YouTube channel. So tonight we shall be concluding damped oscillation in physics 113. Alright, so a question is on the board that says a simple pendulum of length 22 meter is set into oscillation with amplitude 0.05 meter. Amplitude, which means that CO is equal to 0.05 meters. After 5 minutes, which means that the time is what, 5 minutes. But we are not calculating 5 minutes, we have to convert to what, seconds. In doing that, we say 5 times 60, we have what, 300 seconds. Alright, it has fallen to 0.025, which is what which is x, which is the displacement of distance 0.025 meter. Do not forget the formula I gave in our initial class. I gave us that x is equals, that is initial amplitude exponent minus 1 over 2 w squared t, w squared t. So x here, which is the displacement of distance, is what, 0.025 equals 0.05 minus 1 over 2 w squared, the t is what? You say 300, okay, w squared 300. Alright, w squared 300. Now 300 of course is what? The time. And the next thing you do is to divide by 0.05, 0.05, alright? 0.025 divided by 0.05 is 0.5. So this will go into this. Sorry, exponent. Where's my exponent? So 0.05 exponent. Very important. It's not what you should omit. So this is out, and now that exponent minus 1 over 2. Okay, no need for that. So 2 here 1, 2 into 300 is what? 150. 150. And I have that w squared 150. Alright. The next thing you do is this exponent, as soon as it crosses, it becomes minus in. That is natural log of 0.5. You say minus in 0.5 equals what? Minus 150. Minus what? 150. So this minus can get out. Natural log of 0.5 is 0.693. Then equals w squared 150. So you have divided both sides by 150. 150. So this will go into it. It means that w squared is equals what? 0.693 divided by 150 equals what? 4.62 times 10 raised by what? Minus 3. Is that the final answer? No. He said we should calculate for what? The relaxation time. Calculate relaxation what? Time. Now, in our previous class as well, I gave us relaxation time to be 2 over w squared. 2 over what? W squared. So it means that relaxation time now is equals 2 over 4.62 times 10 raised by what? Minus 3. So relaxation time is equals 2 divided by this. That's 2 divided by 4.62 equals, I'll have 0.43 times 10 minus what? 3. So it means if I want to re-express this, I'll be having it to be equals, now this is the standard form, there's what? Minus 1. Because of this 0, you have to do what? Minus 1. Alright, and I have, okay, this minus, as soon as it crosses, as soon as it goes up, or let me simplify it for us. Now you have C arrow is equals what? 2 over. Now this 10 raised power minus 3, it means that 0.00. Then what do you have? 462. We therefore say that 2 divided by 0.00462 equals 432.9 what? Seconds. 432.9 seconds. Alright, so that is what you have it to be. Okay, so let me check something. 4.62. Yeah, so it is very, very correct. So which means that the relaxation time is what? 432.9 seconds. Let me check what they got, because then it shocked me sometimes. Where is it again? 432.9 seconds. So it is very, very correct. It is very, very what? Correct. Now the next question is this. The equation of a damped oscillation is given by the equation of a damped oscillation. The equation of a damped oscillation is given by x. Oh God. Is given by x equals 3 exponents minus 0.5 t minus 0.5 t sine r t. He said calculate the particle velocity. Now whenever you see a question like this, what do? You write out your formula. I gave you formula as initial amplitude exponent minus 1 over 2 w squared t, then sine, okay, w squared t, then cos angular frequency plus what? Phase angle. I gave us this formula in our previous class. Now look at what we have here. You don't need to be told that the amplitude is 3, just as compared. Now this w squared is this one, this 0.5. But it's also calculated for the what? Particle time. Take note, whenever equation of motion in a damped system is given, ending with sine. So you say particle velocity is equals times 1. Now this is the amplitude and this is what? W. This is the angular what? Frequency. To calculate for the particle velocity, you say amplitude times what? The angular what? Frequency. Angular frequency. Now which means that particle time is equals 3 times pi. Look at it here. Comparing it, you observe that this angular frequency has been occupied by what? Pi. Has been occupied by pi. And pi is what? 3.143. So what do you now have? 3 times 3.143 equals 9.429 meter per second. Alright. What are the options? We said 2.08 meter per second, 8.43 meter per second, 1.25 meter per second, D 0.75 meter per second, and E none of the above. So the answer is what? None of the above. So the last one is said the equation of a damped oscillation is given by the formula x equals what? 5 exponents minus 0.25t sine, cos pi over 2t. Find the magnitude of the particle velocity at oscillating or at an oscillating point at t equals what? 0. We have to calculate for the what? The particle velocity. Now, I gave us a formula. This is when the equation ends with sine, alright? But this one ends with cos. So you say Vp equals what? W as how do I put it now? As angular frequency. Definitely that will come first. Angular frequency times 1 over 2 squared. Alright, angular, that is this the amplitude times 1 over 2 and W what? Squared. From the question you have it to be what? You have it to be 0.25. So everything here is 0.25. And you now have 5. So Vp is equals what? Amplitude is 5 times 0.25. Alright. What do you now have? I'll now have it to be 5 times 0.25 equals 1.25. The answer is 1.25 meter per second. So that is what they got here. 1.25 meter per watt second. 1.25 meter per watt second. So what is the other point? Now they said, it's 2.6, which is the last example for now. 2.6, the equation of a damped harmonic oscillation is given by the equation of, I'll not rub off this very one. The equation of a damped, the equation of a damped harmonic oscillation is given by x equals 3 exponents minus 0.04 then cos theta what? T. Alright, so we have to calculate for what? They said what is the nature of the oscillation. So we have to compare. We must compare this to this. Alright. So I told that, I told you for you to know the type of damped system, I said when the angular frequency is greater than 0, you say such is called what? Lightly damped system, right? When the angular frequency is less than 0, such system is called what? Heavily damped. It's heavily what? Damped. This one is negative and this one is what? Positive. But when the angular frequency is equals 0, when the angular frequency is equals 0, you say it is what? It is critically what? Damped. I gave us everything, all of these in our previous class. So they are telling us they're asking us what nature of damped system is found in this question. So we'll compare it. So you have, looking at what we have here, what is occupying the position of angular frequency is what? Theta, which is pi, sorry. So angular frequency is equals what? Pi. So which means that angular frequency is equals what? 3.14t. So what nature of oscillation is this? It is called what? Lightly damped oscillation. Lightly damped oscillation. Because W is greater than what? 0, and you have to be what? 3.143. So at this point, we call it a day. Thanks for watching. Do have a wonderful night rest. Please subscribe to my YouTube channel. Please have a wonderful night rest. Subscribe to my YouTube channel. Thanks for watching.